Thank you for the invitation. Just 1 second. Okay, I open my presentation. Okay. So thank you for the introduction. As you say, I'm a part of Cucinella Architects, and today I would like to show you some of the work that we have done in the last 5 years, and especially our research on 3D printing, because we think that at the moment is one of the technology that we have in architecture that can better help us into creating a sort of biodiversity in our world, no? We need the technology that are able to customize and to go in empathy with the place. And we think that, and I hope that I can show to you some ideas and some projects that we developed that can show you how it's possible to use 3D printing to connect our design with the place where we are. So briefly about us, as you mentioned, we are an office founded by the architect Mario Cucinella in 1992. And as you can imagine, we are an office based in Bologna, in Italy, and in Milan. And we are not just architects, we are a company that is composed of model maker, artists, artisan, storytellers, visualizers. So we have multiple people inside the office that can help into facing all the issues of our world, of our work. So, oh, sorry. So what we think when we design is that we have a very big responsibility. When we design, we are designing for the life of the people. Now we are working on and with the people that will use the building that we are designing. So it's a big opportunity, but a big responsibility. And to do this, the architect starting spoke about creative empathy. So to use the empathy to stay in contact with the place where we are. So when we approach a new building site, each time we start from analyzing the culture of the place, analyzing the society of the place, and of course all the weather condition, the materials. So we try to understand as much as possible from, a scientific point of view, what we have in the context that we are approaching. So, usually nowadays everyone is spoken about sustainability, but we don't think that sustainability is just a function, is more than this, is something that can be and must be connected with the beauty. So, just to showing and to recognize what we need to face in the next year, if we take a look into the global challenges, we need that we are trying to reach some very high and difficult point for the reduction of emission. And we need to know that our sector is the main responsible for this, because the 34% of the global energy is used from the construction, and the 37% of the CO2 emissions are related to our sector. And what is absolutely relevant today, and what we strongly believe, is to pay attention on the materials and the technology that we use to build our buildings. Because if we imagine the CO2 emitted for the total life, for the lifespan of the building, we need to know that in the first 4 years, so for the material production and for the construction phase, we spend something like the 50% of the total amount of CO2 generated to build a building. In this case, we are speaking about an office building. But imagine that the operational phase is only the 50% of the total amount. So deciding at the early stage of the process of design, the material that we will use and the technology that we will use will reduce a lot the stress on the planet and the emission of our building. Of course, all the calculations that we have done since now are based on the population that we have currently in the world, but we know that we are growing. So of course we need to find, disruptive technology that can help us into, decrease this curve. Otherwise, there are no way to having a greener future. For this reason, the office, Mario Cucinella decided since the beginning to have a unit of research and development inside the office. So the mission of our unit is to study new process, new technology, new software in order to help the office and to grow in a better way. We do this not only by taking a look on the future, because we are so connected to the cultural root of our, work as architect. So in each project, we try to start with a vernacular project or to ancient material and try to find a way to take a look with this basement on the future. Of course, one other of the main part of our work inside the unit is to make all the environmental analysis and all the integrated design that we need when we design buildings and master plan in our cities. So in that sense, we can say that inside the office, the research inform projects. So we help our colleagues that are working on projects, and in a sense, the projects are inspiring us for new research. So it's a continuous loop where we work with the other in order to increase the potential of our design. Let me show now some projects that we developed in the last year, and I think that we can go deeper in what I said at the beginning. So the creation of an ecosystem with a sort of biodiversity of buildings. The first one is Tecla. It is a project developed together with WASP, an Italian company that produced 3D printers, and it was developed across the COVID in 2020. It was a prototype. And to do this, we started by taking a look into what, at the time, all the research and the Institute of the Research were saying, so that thanks to 3D printing, we can reduce the time, reduce the cost of our building, having more flexibility in terms of design, reduce the waste, and of course, reducing emission and injuries. So everything was showing us that potentially this could be a technology for reaching the zero footprint of our buildings. But as I mentioned, in the office, we don't want to use something of apparently new without taking in consideration something from the past. So for this reason, we decided to start by taking a look into ancient architecture made with earth. One of the reasons why we decided to use earth, of course, is that because this is a very cheap material and a very ecological material. But one of the other reasons is that all the projects that you can see in this slide are from different parts of the world. But in all these cases, there are no blueprint about this project. And this is something similar to what happens when you use 3D printing, the 3D printing. So when you are using a 3D printer, you don't need a blueprint, you don't need a drawing, you just need a code. So it's something that is so similar to what happened in that kind of building that are just transmitted to the other by speaking, not by drawing. So this is one of the very big similarity with a very modern process like computational design and 3D printing and vernacular architecture. So we decided to work in an algorithmic point of view, and we decided to create a sort of algorithm that we developed together with SOS, the School of Sustainability founded by the architect Mario Cucinella in 2015. And so we started with two questions. Who will be the owner or the user of the building? and where the building could be located. By using the location, we extract climate, the materials, and the resources that we can find in the context. And with this, we develop strategies. With all these strategies, we develop a bottom-up solution that, starting from the wall, can arrive to a final master plan. So this was one of the first sketches of the architect Mario Cucinella when we started discussing with him about how we can create an environment designed for 3D printing, not just a shelter, not just a home, but a sort of environment that is the results of a material and a technology. So together with the students of SOS, we started imagining how these algorithm can work in different latitude and different climate. And as you can see, we start with these 4 initial stage, and together with the students, we develop these 4 different solutions. So we customize the envelope of the building in order to stay in contact with the communities and the different weather. So by using the same technology, we designed 4 different type of wall in order to face with different condition, and we arrive to the case studies of Bologna. So one of the 4 initial context was Italy, and we decided to start with this initial mock-up of an house. So we start with the primitive surface that are the result of FM analysis, and we use this primitive surface in order to make an irradiation analysis on it and understanding where is needed to corrugate the surface in order to create a self-shading on the envelope. So thanks to this, we designed a shape that is something like a human skin. So it's a multi-performative skin that can protect us from rain, protect us from the sun, and having inside it this system of natural ventilation that can help in reducing the heating effect during the summer and reducing the moisture inside the wall during the winter. Okay, so those are some renders at the initial stage, so how it could looks like if all the whole process will work. And here you can see how we manage all the material that are composing the house, because you need to consider that it's possible potentially to use 3D printing for everything. But in our case, we decided to use 3D printing just for the external shell. The whole ecosystem of systems, the electrical system, the water piping, and all those parts are everything connected and embedded inside a container for the transportation. So all the dimension of windows, roofing, and everything is potentially be moved inside the container. So you can consider that we have a sort of high technology part, so the system part, and the low technology part, the shell. So if we imagine to leave the village or the house without all the systems, it will come back to the nature because it is composed of soil. It is composed of soil, and we worked a lot on it. Here you can see a diagram that shows to you all the material that we add to 100 kilos of soil. So all those are mix that we have developed together with WASP and MAPEI in order to have a printable soil. Usually the soil is used to make brick. In our case, we use it to print. So we need a paste, a fluid paste that can dry without cracking. So it was more or less, it was a little bit tricky, but at least by adding silica sand, we manage a good printability paste. Here you can see the structural system. So all the white part on the left are not considered in the structural analysis because the structural part was only the blue ones. As you can see on the right, section by section, from the bottom to the top, we removed some part of the printing path in order to reduce the weight of this wall. And this can allow us to reduce the stress on the initial part of the wall. Here we have the analysis that we have done, we have performed in order to understand the deformation during the printing process. Because the process is quite long, it taken something like 3 weeks. It was, I mean, the first test, but we need to understand, I mean, the deformation that we can have along the process in order to predict it and avoid it. So here we have a video of the building site phase. As you can see, we used the 2 machines able to print together. So a lot of work was done in order to have a shape that can be printed from these 2 machines of WASP. So the work was quite challenging and tricky because it was the first time in 2020 where 2 machines print together outdoor with the real environment condition. And yeah, I mean, here you can see the roughness of the material that is absolutely earth digged out from the building site. And here we have a time lapse of the building. These are some of the most critical part of the building site. Here you can see the biggest amount of material was soil, considering that we use something like 60 cubic meter of soil for 200 hours of printing. Okay, and here we have some image of the final part of the process and the completed mock-up with windows, doors, and all the furniture inside. Here you can see, I mean, the lighting system that we designed in order to create more, I mean, comfortable space inside. And I mean, we just put a tree inside the space in order to, I mean, showing the connection with the earth. So after this project, we decided to take a little bit of time in order to understand how we can use these technologies in different contexts. At the time when we started with Tekla, the challenge was to having bigger machinery able to print on site, to build big buildings, and having something that can be monolithic in the site. But we have seen that having machinery like this could be a very big effort in terms of energy and in terms of space. In some context that we have with other clients that we are working with, it's not possible to set up a machine like this and cover the whole time of the printing inside the building site. So for this reason, we start trying to understand how we can split an architecture into parts in order to be potentially built off-site. Because just splitting the surface and cutting it is something that can affect a lot the aesthetic of the building. For this reason, we decided to start understanding a little bit better what happens when we are printing something. So if we take a look into a 3D printed material, we needed to know that inside a block of 3D printed material, that could be different percentages of material. So there are patterns that are composing our material. So our material is not fulfilled of a dense part, but it's filled with this kind of geometry. So we started to imagine how it can look like if we remove the external shell and the internal shell and showing what is the infill of our 3D printed element. For this reason, we start thinking and trying to understand how it looks an architecture that is mainly based on geometry like this, so on the 2D patterns, and we're trying to find a way to create blocks based on this pattern, able to be used as a sort of interlocking system, a brick system, no? We discussed it internally with the architect Mario Cucinella and with Buro Milan for the structural part. He's one of our partners. And I mean, we know that some of the biggest buildings in the world made in the ancient time are made of bricks. So why we cannot use 3D printing to make a new kind of bricks that can help us in build without using glue, so creating a dry assembly object that can be modified with no new material along the time. So creating something really, adaptable along the time. And why we use 3D printing? We use 3D printing because it's the cheapest solution for an architectural office to test in the physical world new geometry. So in that case, we tested this initial stage in just 1 week. This is ceramic, so we fire this ceramic and we use these kind of new bricks in order to test the junction system. And after 1 month, we have the full scale blocks and we test at the real scale. So we are speaking about blocks of 60 centimeter, and we test the structure at this scale in the lab. The first opportunity to use this new approach of 3D printing was the Milano Design Week of 2024, when we have the opportunity to design for the Roca company an installation that's showing to people this very big innovation made by the company. They create a very new electrical kiln for firing ceramic. And one of the main behavior of this kiln is that they can control perfectly the temperature curve inside the kiln. So for this reason, what we have done is to design and materialize this curve of temperature in order to show to people the process of ceramic firing. So we recreate inside the space in Milan this curve, and we materialize this curve with the blocks that I show to you. To make this block, to make these 1,200 blocks, we use the recycled ceramic, so 50% of recycled ceramic and 50% of raw ceramic. And we print all these blocks. So as you can see, we use those like Legos, and we assemble these blocks in less than 1 day in the building site. So is a very difference in terms of use of printing, because we spend the whole time in the warehouse to print the blocks, something like 1.5 months, and we assemble everything in just 1 day. As you can see, everything is made with the same type of block. And thanks to this, Roca reused the same material for 4 different exhibitions. Usually in exhibition, the material every time is destroyed after the exhibition. But in that case, thanks to this design, they reused the material 4 times. One other project that I want to show to you is Un Fiore for San Servolo. It is on the San Servolo Island in Venice, and it was done in the southern part of the island, one of the most unused part of the island. And basically the idea was to reappropriate and retake the nature inside this space. It is a football pitch, unused. And basically, the idea of the municipality was to use this space for art and cultural event. So they want a sort of theater in that part of the island. For this reason, we started from the amphitheater shape, and we tried to, play a little bit with it in order to create a more organic shape, and on one side to create a sort of perspective cone that can help us into taking a look into the island of San Lazzaro agli Armeni. So here you can see a 2D representation of what happened. So we use just half part of the football pitch, and we create this cultural space made of blocks. But you can imagine that produce custom elements in the island is quite complex due to the, all the costs and all the issues of the transportation on an island in the Venice lagoon. So for this reason, we decided to split in blocks and to print all these blocks on the island. For this case, we don't use raw earth, we don't use ceramic, we use limestone. Why we use limestone? We use limestone because it's one of the oldest material used in the Laguna of Venice. It is the material that they use to connecting together bricks. So it's something that can resist really well on the salt and the moisture of the space. And we shaped these blocks in order to having more stability during the printing process. Because you need to consider that during the printing process, having a really aligned walls could be an issues point. So here you can see the printing phase on the island. So we set up the machine on the island, a robot, a 6-axis robot, and we print all the blocks, 700 blocks on the island. Here you can see the first test that we have done. Here you can see the stocking place where all the plates were stocked, and some assembly moment of the building site where we put all together. This was the initial render of the installation, and this is the final result. Not the final result, is a working on phase. Those are some images of the final results. In the night view, with the grass and plants inside. And this is the final stage, a couple of hours before the opening of this installation for the island of San Servolo. Here you can see why we design with this opening in order to showing the lagoon and the island of San Lazzaro agli Armeni. The last project I want to show to you is a similar project we developed for Artesella in Trento, so in the north of Italy, on the mountain, on the Alps mountain. And this project was done in a sort of answer to the Via storm that destroyed part of the ecosystem a couple of years ago. So we decided to create a discrete landscape that can protect people inside this art park in the Alps space. So we design something that can be done by using local material, like the material produced from Calchera San Giorgio, that is a local company that produces limestone, and Erratic, a company that works with robots very close to the building site. So we started working and testing local aggregates with limestone, and we shaped these kind of basaltic element that grows from the soil in order to protect people that are inside the park. So here you can see some image of the final stage that is fully designed and fully printed. It is composed of 500 blocks with 57 different blocks. Here you can see how we connect the architecture with nature. Now, basically, the idea is to reconnect our work with nature, and potentially in the future, these elements will become a part of the nature. Here are some details of the building, and as you can see, the color of the blocks is so similar to the color of the soil, and this is due to the fact that the material is composed at the 40% with natural aggregate. So yeah, that is all. So thank you for the attention. And yeah, I hope that I have showed to you some interesting project from our studio and our experience in the land of 3D printing.